Welcome to The Explainer. Today we're jumping into a scientific puzzle that is, well, it's pretty bizarre and surprisingly bright. We're going to uncover the mystery of the glowing pickle. So let's just dive right in with a scientific demonstration that sounds like something completely made up, but I promise you it is 100% real. And there it is. That is an ordinary dill pickle, straight from the jar, connected to an electrical current. And yep, it literally lights up with this kind of spooky orange glow. So the big question is, what is going on inside that pickle? How on earth can it conduct electricity and then produce light? To solve this, we've got to look past the green skin and dig into the chemistry within. That's where the real secret is hiding. Okay, to really get how this works, we first have to talk about the liquid our pickle has been soaking in. We need to explore the world of solutions. At its very core, the pickle brine is a perfect example of what we call an aqueous solution. That's really just a fancy way of saying it's water that has other stuff dissolved in it. Now, in any solution, you've got two key players. First up is the solvent. That's the stuff that does the dissolving. You can think of it as the host of the party. In our pickle's case, the solvent is water. And the second player? That's the solute. This is the stuff that gets dissolved, the guest at the party, if you will. For our dill pickle, the most important solute is, you guessed it, salt. Now here's a crucial point. Not everything can dissolve in everything else. It all depends on their chemical nature. Chemists have a super simple rule for this, and it's a great one to remember. Like dissolves like. Basically, substances with similar chemical properties will happily mix together. This is so cool because it explains so much everyday chemistry. Water is what we call polar. It has a slate electrical charge. So it's great at dissolving other polar things, like salt. But then you have nonpolar stuff, like gasoline, which dissolves other nonpolar things, like oil and grease. This is the exact reason why oil and water just don't mix. They're just too chemically different. Okay, so we have a major clue to our pickle mystery. We know salt is dissolved in the water. But what is it about that combination that makes it so special? So special, it can conduct electricity. The answer, my friends, is electrolytes. Yep, an electrolyte. This is the secret ingredient that turns a boring old solution into an electrical superhighway. It's any compound that can conduct an electric current, but only when it's dissolved in water or melted down. And here's the magic behind it. When an ionic compound like regular table salt, sodium chloride, dissolves in water, it doesn't just spread out. It actually breaks apart into tons of tiny charged particles. We call these ions. The whole process is called dissociation. Now, since pretty much all of the sodium chloride in our pickle brine breaks apart into ions, we call it a strong electrolyte. This creates a solution that's just swarming with mobile charges, which basically turns our pickle into an amazing conductor of electricity. Of course, on the flip side, you have weak electrolytes. These are substances that are a little more reluctant to break apart. They only produce a few ions, so while they can conduct some electricity, it's pretty weak. It's kind of like the difference between a bright floodlight and a tiny little nightlight. And finally, there are non-electrolytes. Let's say you dissolve sugar in water. The sugar molecules spread out, but they don't break apart into ions. They stay whole. And with no ions, there's no path for electricity to flow. So you think a pickle soaked in sugar water would glow? Nah, no way. And get this. This isn't just for pickles. This exact same principle is working inside our bodies right now. Our nerve cells use electrolytes, specifically sodium and potassium ions, to carry the tiny electrical signals that let us think, move, and, well, live. All right, before we put the final piece in the puzzle, let's take a quick but really fascinating detour. We're going to explore another way water interacts with compounds, but this time when they're solid. This will give us an even better appreciation for just how amazing water is. So sometimes when crystals are forming, little water molecules can get trapped inside. They actually become part of the crystal structure. You can think of it like a molecular sponge that's holding on to water. We call this special kind of compound a hydrate. And here are just a few examples you might actually have at home. See how the formulas have that little dot and then H2O at the end? That's the water of hydration. It's part of the chemical makeup for things like Epsom salts and borax. Pretty cool, right? And, we can even calculate exactly how much of a hydrate's weight is just from that trapped water. It's a pretty straightforward process where you just compare the weight of the water to the total weight of the whole compound.
It's sort of like figuring out what percentage of a cupcake is just the frosting. Now, this property leads to some super useful materials. Some compounds are hygroscopic, which is a fancy word meaning they are so thirsty for water they can literally pull moisture right out of the air. We call these things desiccants, and you've definitely seen them. They are those little packets of silica gel you find in a new pair of shoes, just working to keep everything dry. All right, the moment has come. It's time to bring all these ideas together: solutions, electrolytes, ions, and finally crack the case of our glowing pickle. Let's solve this thing. So we're back where we started, looking at this glowing pickle. But now we have the tools to understand what's really happening. This isn't magic. It's just really, really cool chemistry in action. Okay, so here's the grand finale. The pickle itself is just a container for a really strong electrolyte solution. The salt from the brine has dissolved and broken apart into a whole sea of free-moving sodium and chloride ions. So when we pass an electric current through it, those ions get to work. They act like little couriers, carrying the charge from one fork to the other. This current flow heats the pickle up, and all that energy makes the sodium ions so excited that they start to release light, that classic yellow-orange glow. And that is how you make a pickle glow. So when you think about it, from the sports drinks we use to rehydrate to the batteries that start our cars, electrolytes are these hidden conductors that make so much of our world work. So the next time you see a pickle, maybe you'll remember the incredible chemistry that's hiding inside. Makes you wonder, what other everyday objects have a secret scientific life?